Okay, let's continue our discussion about area under a curve. We know that from our previous sections and videos that area under the curve of a function is the same as the definite integral from a to b. But I want to do example number 5 with you because it's going to look a little bit different. And so example number 5 says to find the area of the region between the x-axis and the graph of f of x, if f of x is x squared minus 3x, and I want you to find the area from x equals 1 to x equals 3. And so on this example, I've provided you with a picture. Now, a picture is not always going to be given, so you've got to be careful. But the picture here shows us that we have a parabola and that we want to find the area between x equals 1 and x equals 3. And it says between the graph and the x-axis. So we're talking about this kind of blue or red shaded area now, right? And so a mathematical notation for finding the area between the x-axis and the curve from x equals 1 to x equals 3 is the definite integral from 1 to 3 of x squared minus 3x dx. So I can set up a calculus problem that says I want to integrate x squared minus 3x from 1 to 3. So then I can use my fundamental theorem of calculus. I can use my rules of integration and add 1 to the exponent, divide by that new exponent, and then I'm evaluating it from 1 to 3. I can plug in my upper limit, I can plug in my lower limit, and then I can subtract those two values. And I end up getting, this looks a little bit different, doesn't it? I end up getting negative 10/3 as the area underneath the curve. Now that doesn't quite make sense when you're talking about area because area should never be negative, right? And so what do you think that means when our answer turns out negative? Because on all the other problems we've done, our answers were positive. Well, what it means is that our area happens to be underneath the x-axis versus above the x-axis. When we have area above the x-axis, the answer ends up being positive, but anytime our area goes below the x-axis, we have a symbol for that in math, we have negatives, right? And so then we have a negative 10/3 area. Now my area is still 10/3, the negative just represents that it's below the x-axis instead of above. But the example is there on purpose because I need you to be really careful depending on what the question asks. Before we do our next example, I want to kind of give you kind of a real world scenario of when you have to be careful of positives versus negatives, above the x-axis versus below. So if I give you a marginal profit function, remember that's the rate at which profit is changing. That's the derivative of profit. And I ask you to integrate that from 0 to 5. What I'm really asking you to do is find the area underneath the curve of that marginal profit from 0 to 5. And when we integrate marginal profit, what we're really finding is the original, is the amount of profit from 0 to 5. But if some of it is above the x-axis, that means I have a positive amount. So let's say this is, $10,000. And it's a positive $10,000. That's the rate at which my profit is changing. And when I find the area, that's the amount of profit I had. So from 0 to 2, let's say 0 to 2 years, I made $10,000. But from 2 to 5 years, my marginal profit ended up being negative. That means the rate at which my profit was changing was decreasing. And so I ended up with a negative $3,000. And so when I go to integrate it from 0 to 5, I end up with a change in profit from 0 to 5 of really only $7,000. I had positive 10, but then I had a negative 3. And so my net change from 0 to 5 is really only $7,000. So you've got to be careful depending on what the question asked. Because if I change that question and I said, what was the total change? Well, I had a change of 10,000 and then I had a change of 3,000, which is really a total change of 13. Now, I didn't grow by 13, but there was a total change of 13 versus a net change